Welcome to algorithm video series. Today let's discuss count of occurrences problem. The problem statement is given a sorted list containing duplicate elements and a target value, return the number of times the target appears in the list. Our input is a sorted list containing duplicate elements and a target value. Output is number of times the target appears in the list. For an example, here we have a sorted list with elements 10, 20, 30, 30, 30 and 30. Now our target is 30. Then we'll get output as 4. 30 appears 4 times in this list. 1, 2, 3, 4. Then if I take target as 10, output is 1. It appears only once. That's why output is 1. And we can solve this problem using different techniques. Here we'll talk about linear search method and binary search method. In linear search algorithm, we'll search for the target element in sequential order, right? Initially, we'll compare the target element with the first element of the list. Here, if I compare 10 with 30, 10 is equal to 30. No. Then we'll compare the next value with the target element. Here, 20 is equal to 30. No. Then let's compare next element of the list with the target element. 30 is equal to 30. True. So what I'll do is I'll take a variable, for example count, and I'll take count as 1 now. Because here target is found, I'll take count as 1. In the normal linear search, once the target is found, we'll return its index and we'll stop. But here we want to find how many times the target appears in the given list. So what I'll do is I'll continue searching and I'll go to the next element. Here next element is 30 and I'll compare that with the target element. Yes, it is true. So I'll take count as 2 now. Count of 30 is 2 now. Again, go to the next element. Here 30 is equal to 30. True. Count is 3. Again, go to the next element. 30 is equal to 30. Yes. Count is 4. Next, we don't have any other elements to check. List ends here. So, count is 4 now. Our target value, that is 30, appears 4 times in our given list. Let's take our target as 10. Then compare the target element with the first element of the list, that is 10. 10 is equal to 10. True. This condition becomes true. So, I'll take count as 1. Then go to the next element. Here 10 is equal to 20. Target is 10 and element is 20. No. Next, go to next element. 10 is equal to 30. No. 10 is equal to 30. No. Next, 10 is equal to 30. No. Again, 10 is equal to 30. No. So, we don't have any other elements to check here. List ends here. So, count is 1. 10 appears only once in the given list. We can modify linear search algorithm like this to calculate how many times target appears in the given list. But as we know, it is better to use binary search when we are dealing with the large data sets. And also here, as mentioned in the problem statement, list is a sorted list. So let's see how to solve this problem using binary search algorithm. Okay, in binary search what we can do is, first we can find the first occurrence of that target element using binary search. Then find the last occurrence of that target element using binary search. Then you can find the count using this formula, last index minus first index plus 1. Okay, let me explain this with an example. First what we need to do is, we need to find the first occurrence of the target element. We already discussed about this in the previous tutorial, right? How to find the first occurrence of the target element using binary search algorithm. So we'll get the index of first occurrence of the target element in the given list. So for example 10 here. So 10 is occurred at 0th index. Then you need to find the last occurrence. Here last occurrence is also at 0th index. Because 10 appears only once, this is the first and last occurrence of 10 in this list, right? So first index is also 0, last index is also 0. Then how to calculate count? Here last index minus first index plus 1. Why plus 1? That is because index starts from 0, right? Here we need count. That's why we need to add plus 1 here. So 0 minus 0 plus 1. So we'll get count as 1. True, right? Here 10 appears only once. So count is 1. Next, let's take another example. Okay, let's take target as 30. First, calculate the first occurrence of 30. Here in this list, first occurrence of 30 is at index 2. Then the last index. Find the last occurrence of 30. Last occurrence is at 5th index. First occurrence is at index 2. Last occurrence is at index 5. Now here let's calculate this. 5 minus 2 plus 1. 5 minus 2 is 3. 3 plus 1 is 4. So total count is 4. 1, 2, 3, 4. So using binary search, what we need to do is, first we need to calculate the first occurrence of the target element in the given list. We need to find the index. Then we need to find the index of the last occurrence of the target element in the given list. Then using this formula, that is last index minus first index plus 1, we can find the count. And how to find the first occurrence and last occurrence of the target element using binary search algorithm? We already discussed about this in the previous tutorial. So I'll give you the link of that in the description box. Alright, next let's write the program. Okay, here linear search. Let's modify this linear search algorithm first. Here in this linear search function, initially I'll take a variable count. Count is equal to 0. Let's go through the elements of the list one by one using for loop. Then compare the element of the list with the target element. Then here we don't want to return its index when target is found. We don't want to return its index. Instead of that, I'll take count is equal to count plus 1. I'll increment count and go to the next element. After searching entire list, then here we need to return count. Okay, so this linear search algorithm will find how many times target element appears in the list. Then here input is same, a list. Here we need a sorted list, remember that. Then a target element. Then here we'll call the linear search function. Here result is count, right? So if result is 0, then that means the target element is not present in the given list. So we can print that message. If it is not 0, then we can print here. Okay. Let's save this and execute this now. Let's take 5 elements. Let's enter the elements in the ascending order. Let's take 30. It appears 3 times. Let's enter 50. 50 appears 1 times. 5 is not found in this list. Okay. So this is how we can modify linear search algorithm to find how many times a target element appears in the given list. Next, let's talk about binary search algorithm. So in the binary search algorithm, what we need to do is, first we need to find the first occurrence of the target element. Then we need to find the last occurrence of the target element in the given list. Then we need to use the count formula to find the count, right? So here initially let's change this function name. We'll use binary search but modified binary search. Here I'll just change the name to first occurrence. Alright. Then here what we need to do, to find the first occurrence when target element is equal to middle element, we need to store that result. Let's take a variable answer equal to -1 initially. Then store the index and search in the left side. To search in the left side, I equal to mid -1. Here you need to return answer. I won't explain this again because I already made a video on this. So I'll give you the link of that in the description box. Fine, right? Next here, we need to find the last occurrence. So I'll copy this and let's define the function for last occurrence like this. Here, let's change the function name to last occurrence. Here, in the last occurrence, when target element is equal to middle element, we need to store the index and we need to search in the right side. So low equal to mid plus 1. Done. Okay, so this is first occurrence. Here last occurrence. Done. Next here for first index call first occurrence. For the last index last occurrence. Done, right? Call both these functions. We'll get first index and last index. Done. Next here I'll check first index is not minus 1. So when we find first occurrence and last occurrence, if the function first occurrence return minus 1, that means target is not found, right? That's why I'll use this condition. You can use last index is not equal to minus 1 also, because if target is not present in the given list, we'll get minus 1 as the value for first index and last index. Both this function will return minus 1, right? Here I'll take first index is not equal to minus 1. Then how many times? That is, let's calculate that. Count is equal to last index minus first index plus 1. This is the formula. Then here you can print count times. Okay, done. Let's save this and execute this. Let's enter 6 elements. Enter the numbers in the ascending order. Okay. Let's enter 20. 20 appears 4 times. Correct. 5. Let's enter not found scenario. 6 is not found. 10 appears 1 times. Okay, so this is how you can use binary search algorithm to find how many times the target element appears in the given list. So that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.